Now that we've covered the fundamentals of pasture, rangeland, and forage insurance, let's look at one of the most valuable resources available to producers, the USDA Pasture, Rangeland, and Forage Decision Support Tool. In this demonstration, we'll walk through the tool step by step. We'll cover how to locate your operation, select a rainfall grid, review historical rainfall index data, and interpret the data provided. First, search USDA Grid Locator into your search engine and select the PRF rainfall options seen here. You will then navigate to the Grid Locator tab. That will give you a map of the United States. Use your cursor to zoom in on the general location of your ranch or farm. Once you have zoomed in far enough, grid lines will appear across the map. You then will be able to place a pin on your operation's location within the grid you choose, giving you the grid ID. Write this number down. Next, navigate to the Historical Indexes tab next to the Grid Locator tab. This will open a page to search your operation by grid ID. Once you have searched your grid ID, a table will appear. This table shows the rainfall index for every PRF interval within a specific grid. In this example, the producer is looking at grid ID 27356 in Owyhee County, Idaho. Each row represents a year, and each column represents one of the 11 PRF coverage intervals. The numbers are expressed as a percentage of normal rainfall for that interval. A value of 100 equals exactly average rainfall. 110 equals 10% above average rainfall, while 90 equals 10% below average rainfall, and so on. Remember, these are not inches of rain. They are comparison to the historical average rainfall for that interval. Looking at the May-June interval in 2024, you can see the average rainfall was 58.6. This means rainfall was only 58.6% of normal during that period. If a producer selected 90% coverage, the trigger level would have been 90. Since 58.6 is less than 90, an indemnity would have likely been triggered for that interval. Next, we are going to navigate to the Decision Support Tool tab on the right of Historical Indexes. The Decision Support Tool allows you to test different strategies for coverage and compare how they would have performed historically. We will start by filling out the Protection Information box. In the Intended Use section, decide whether you are using your land for haying or grazing. For this example, we will select grazing. Next, select your preferred coverage level. Remember this ranges from 70% to 90%. Then decide what level of productivity your land has. In this example, we will assume the land performs comparable to the county average and select 100%. The next selection is for insurable interest. Insurable interest identifies how much of the acreage you actually own, lease, or have financial stake in, and therefore are eligible to insure. For example, at 100% insurable interest, you own or lease all of the forage acreage yourself, so you insure 100% of the eligible acres. While at 50% insurable interest, you share ownership or lease with another producer, so you're only financially responsible for half of the acreage. Next, you will decide the actual amount of acreage that you wish to insure. In this example, we will be insuring 2,500 acres. And finally, select the sample year. This will show you how your coverage strategy would have performed against the actual rainfall data that was collected from that year. For this example, our sample year will be 2024. Now you will decide which intervals you would like to allocate coverage in. You may choose up to 6 different intervals, and the percentages must total 100%. Once you have decided which intervals you would like to allocate the percentages of coverage in, you will click Calculate. After calculating, this table shows how your specific PRF policy would have performed during the selected year, 2024. It breaks down coverage, premium costs, rainfall conditions, and indemnity payments for each insured interval. Across the top of the tables are labels explaining each column of values. First, the interval that was selected, followed by the allocation amount in that interval. In this example, the allocated intervals are 60% of coverage to May-June and 40% of coverage to August-September. All other intervals received no coverage allocation, which is why they show zeros throughout the table. Policy protection per unit represents the amount of insurance protection assigned to each insured acre after accounting for the county base value, the selected coverage level, and the chosen productivity factor. It is essentially the same as protection per acre. In the May-June interval, it was $22,815. And in the August-September interval, it was $15,210. Because May-June received 60% of the coverage allocation, it receives a larger share of the total protection. Together, They equal $38,025 in total protection. Premium rate charged for each interval is the cost of insuring $1 of protection during a specific 2-month coverage interval. Premium rates differ among intervals because the historical risk of drought is not the same throughout the year. Intervals that have historically experienced more frequent or more severe rainfall shortages generally have higher premium rates, while lower risk intervals tend to have lower rates. These rates are established by the USDA Risk Management Agency and are used to calculate the producer's total premium. For example, in the May-June interval, the premium rate was 24.64, while in August-September, it was 36.68. Notice that August-September has a higher premium rate because drought risk has historically been greater during that period. The next column shows what the total premium for your policy is. It is calculated by determining the premium for each insured interval based on the amount of protection assigned to that interval and its corresponding premium rate. Those interval premiums are then added together, and the final value is what your premium is before any government subsidies are accounted for. The premium subsidy is the portion of the PRF insurance premium that is paid by the federal government, reducing the amount the producer pays out of pocket. The USDA currently subsidizes 51% of the total premium at the 90% coverage level, meaning the producer only pays the remaining 49%. The subsidy helps make PRF coverage more affordable by lowering the producer's out-of-pocket cost while still providing protection against drought-related forage losses. This is the amount of the premium that the producer is responsible for paying after the government subsidy is calculated. The actual index value is how much rainfall was recorded for that period on the scale we discussed earlier. And finally, the estimated indemnity is what the producer may receive after all calculations. Remember that estimated indemnity and premium costs are displayed separately. To evaluate the overall financial outcome of the policy, producers should compare the estimated indemnity with the total producer premium that they paid. Looking into the policy information box located at the left of the table we just reviewed, you will find all the information pertaining to your sample coverage plan. For the year we are sampling, 2024, no more than 70% of your policy can be allocated to an interval. This number can change depending on the year you are testing your strategy on. In general, the USDA PRF handbook specifies to check the minimum and maximum amounts allowed for allocation depending on the year. We will now navigate to the Estimated Indemnities tab to the right of the Decision Support tool. This table shows the estimated PRF indemnity payments that would have been triggered in each year based on the coverage intervals selected by the producer. Each row represents a year. Each column represents one of the 11 PRF intervals. The dollar amounts shown are the estimated payments that would have been received if the producer had carried this exact policy during that year. In 2023, you can see that every interval shows $0. This means rainfall never fell low enough in the insured intervals to trigger a payment. The producer would have still paid the premium, but no indemnity would have been received. Similarly, in 2020, while the August-September interval paid $9,194, no payment occurred in the May-June interval. This tells us drought conditions were concentrated in late summer rather than spring. In 2018, the May-June interval paid $2,053, while the August-September interval paid $14,179. The large August-September payment suggests severe drought conditions occurred during that interval. This is an example of why many producers study historical indemnity data before selecting intervals. A single drought year can generate substantial payments when rainfall falls far below the normal. This concludes our guide into how to use and interpret the USDA's Decision Support tool. Next, we will look at the University of Utah's Historic Rainfall Analysis tool.